Hello, are you there? Do you hear me?
Good afternoon, sir.
Okay. So let us start our second module, your MCS231, that is mobile communication. So uh, mobile communication is the use of technology that allow us to communicate with others in different location without the use of any physical connection. That is, if the communication takes place without the use of any physical connection, any physical wire or any physical cables, so the communication is referred as mobile communication. So mobile communication make our life easier and it saves both time and effort. Nowadays, the widely used our mobile phone uh, is an example of mobile communication. So we are making any communication with the help of our mobile phone or our cellular phone, our hand phone we are using nowadays is a good example of your mobile communication or wireless communication. So when communication is performed by using, you know that using any physical connection is any no physical wire or physical cable is used. It used in other media to communicate without the any physical connection, that is known as your mobile communication. So as you know, to perform a communication, we need at least five components. Absent of one, that is, if there is a absent of any one, you cannot perform any communication. So you know that when we are communicating, your sender device is there. Most first component is sender. When we, from the machine from which you are sending data, suppose you are sending data from your mobile phone, so you must have a devices to send data. Similarly, the receiver who receive data, the second component is receiver who receive data. Suppose you are sending data from your mobile. Similarly, there be another such type of device which is receive data. So the receiver side also. Number three, the data itself. The data itself, the data may be any types. It may be a textual data, graphical data, or a data may be an image, or data be a picture, or data be a audio, video, whatever may be. But the data must be there. That is so the third component is data itself. The fourth is medium. That is, it may be a physical medium, wire or cable or any wireless communication. It may be a Bluetooth. You know that Bluetooth is a wireless medium where you can connect one device to another device within a certain range. Also, there are infrared communication. There are also satellite communication are there. So there are many mobile communication are there also. So the fourth component is the medium. The first one is sender, then receiver, data itself, and fourth one is your data itself. What are
चाट
the
कैसे दे रहे हैं?
भाई तुम इससे नहीं बोल सकते, भाई नहीं बोल सकते मेरे को।
मोटे भाई चाट कैसे दे रहे हैं?
so there is a disturbance. So I'm discussing the data communication, any communication. So for a communication, any type of communication, you need these five components. So first one, the sender, the receiver, the data, and the medium. Four. And the fifth important, Do you know what is the fifth one? The fifth one is the protocol. We will discuss about the protocol. So the protocol is there is a set of rules where the communication takes place based upon that rules. So this is the protocol different, and a protocol you may heard about TCP/IP. There one protocol UDP. There is a different type of TCP UDP. TCP is the IP version 6, version 5. There are different type of protocol are used. So these five components are there. But in mobile communication, the medium, the fourth component is a not a physical component, not a wire, not a cable, any other type component which does not have any physical connection. Feature of mobile communication: high capacity load balancing. So why do we use mobile communication? What are the features? Each wire and wireless infrastructure must incorporate high capacity load balancing. High capacity load balancing means when one access point is overloaded, the system will actively shift user from one access point to another depending on the capacity which is available. That is, uh, if you are, you know that for traveling from one source to destination, when the data is sending, so the sender machine is referred as source, and the destination machine is referred as the destination. So when data is traveling from the sender to destination, there may be different path. There is not a unique path. So if one path is busy, so automatically uh, the access point is overloaded or busy. Automatically the system will actively.
Cihale miskin mukun baranjish bahane hijra.
So this is the first feature. Uh, if one access point is overloaded, the system will actively shift user from one access point to another depending on capacity which is available. The second is scalability. The growth in popularity of new wireless device continuously increase day by day. So you know that the growth of the mobile users nowadays continuously increasing day by day. That is the number of user today today is not equal to, it is too higher than the number of user using the mobile phone 10 years ago. So the wireless network have an ability to start small if necessary, but expand in terms of coverage and capacity as needed without having to overhaul to build an entire new network. So it has the scalability to expand. So if there a mobile infrastructure is there, if the number of user increases, so there need not to construct the new entirely new network. So it has the capacity to it expand in term of coverage and capacity. It can expand that only. So there are no need of having the build an entire new network. So this feature is known as the scalability. Network management system. Nowadays, wireless networks are much more complex and may consist of hundreds or even thousands of access points, firewalls, switches, manage power and various other components. So wireless network are much more complex. So, the wireless network have a smarter way of managing the entire network from a centralized point. It has also the indoor as well as outdoor coverage options. So it is important that our wireless system has the capability of adding indoor coverage as well as outdoor coverage. NAC, Network Access Control. Network Access Control can also be called as mobile device registration. It is essential to have a secure registration and network access control the role of user and enforces policies. NAC can allow the user to register themselves to the network. So when a user is registered to a network, that is, it belongs to that network and any communication takes place using that network. It is a helpful feature that enhances that user experience. Roaming. This is also another feature. It allows the user to successfully move from one access point to another without even noticing a dip in a performance. Suppose when you are moving in a fast moving vehicles, so if you your communication should not be dropped. So when you are moving, you know that during your journey or during moving, the access point changes, the network changes, but the communication which are going on, it will not be dropped. For example, allowing a student to check their mails as they walk from one class to the next. So when you are also moving from a car, you know that you can communicate from your mobile phone. And when you are moving, so there are changes in the access point or network. Switching. Basically, a network switch is the traffic cop of the wireless network. Switching is an essential part of every fast, secure wireless network for several reasons. It helps the traffic on the network flow more effectively. It minimizes unnecessary traffic. It creates a better user experience by ensuring your traffic is going to the right places. So these are the features of mobile communication. Then what are the advantages? Why you are using the mobile communication nowadays? Uh, the first advantage is flexibility. Wireless communication enables the people to communicate with each other regardless of the location. So, as we discussed, when we are moving, we can also continue our communication. There is no disconnection. There is no need to be in an office or some telephone booth in order to pass and receive message. So as unlike the physical connection, you need not to stay in one place for communication. So you can move from one place to another place and continue your communication. Besides that, more important is cost effectiveness. In wireless communication, there is no need of any physical infrastructure or any wire infrastructure, any cable infrastructure, or it's also maintenance practice. So as there is no physical infrastructure, the maintenance cost is also low. That is why the cost is also reduced. So it is cost effectiveness as compared to wire network. So wireless network is mobile communication is cost effective. Speed also. The another advantage is speed. Improvement can also be seen in speed. The network connectivity or the accessibility was much improved in accuracy and speed. So the speed is also faster than the wire network. Accessibility. With the help of wireless technology, easy accessibility to the remote area is possible. For example, in rural area, online education now possible. There are some area which is not possible to construct a wire network. So in those area, the uh, mobile communication or mobile network is preferable. So educator or student no longer need to travel or far flung area to teach their lessons. So due to the mobile communication, those this type of area, the people in this type of area do any type of communication. So although there are no wire network, or it is very difficult to construct the wire network at those places due to geographical infrastructure. So these are the advantages. Then multiplexing. We already know the what multiplex means in simple networking. So let us some uh, uh, idea of what are the multiplexing is. Uh, Access method are multiplexing techniques that provides communication service to multiple users in a single bandwidth wire or wireless medium. That is the bandwidth is single wire, but it can provide service to multiple user. So communication channel, whether they are wireless spectrum segment or cable connects, are expensive. So communication services provider must engage multiple paired user over limited resource to make a profit. So the access method allow many users to share this limited channel, but channel is limited, but the multiple user can access it, can use it to provide the economic of scale necessary for a successful communication business. So you know that uh, in a single cable channel, there are many uh, data are come, even different data in different channel. So the first type of multiplexing method is FDMA, frequency division multiple access. That is here the frequency, as the name suggests, FDMA, frequency division multiple access. That is the frequency divided. Let us see how. FDMA is the process of dividing one channel or bandwidth into multiple individual bands, each user used by a single user. So one channel or bandwidth in multiple is divided into multiple individual bands. Each individual bands or channel is wide enough to accommodate the signal spectra of each transmission to be propagated. So each band is responsible of propagating different type of transmission spectrum or data different signals. The data to be transmitted is modulated onto each subscriber, and all of them are linearly mixed together. So the best example of this is a cable television system. So you know that in your the cable television system is FDMA. That is the line is connected to a TV, but you can view different channel and different programs in a TV. So this frequency is divided. You change the data frequency and get another channel. So the medium is a single coaxial cable that is used to broadcast hundred of channel or video audio programming to homes. So that is a single cable, but it is capable of providing or broadcasting hundred of channel of video and audio programming to the home television, and it is consists of a single coaxial cable. The coaxial cable has a useful bandwidth from about 4 megahertz to 1 gigahertz. This bandwidth is divided up into 6 megahertz wide channel. So the bandwidth is divided into smaller bandwidth, and each bandwidth is carry a particular channel. And the second method is TDM, time division multiple access. It is a digital technique that divides a single channel or band into time slots. Each time slot is used to transmit one byte or another digital segment of each signal in sequential serial data format. This technique works well with slow voice data signal, but it is also useful for compressed video and other high-speed data. So this technique it divide the unlike your previous one, which divide the frequency, but it divide the single channel or band into different time slots. And the example of FDMA was your home television systems, but a good example of the widely used T1 transmission system, which has been used for year in the telecom industry. So this is a T1 transmission system, which a T1 lines carry up to 24 individual voice telephone calls on a single line. So the basic GSM, global system of mobile communication, basically not used nowadays, but initially you may heard about a GSM network. Uh, uh, you may have or may have seen a mobile phone having GSM network. So this cellular phone is TDMA based. It divides up to radio spectrum into 200 kilohertz bands and then use time division technique to put 8 voice call into one channel. So if the voice call is more than 8, it instruct the user to it is the all line are busy, you wait. So all line are busy. So this is your TDM base. Basically, your GSM will learn about to GSM network. It is in your course different type network. And but remember that the GSM cellular phone system is TDMA based. Then the third one is CDMA, code division multiple access. It is also known as spread spectrum because it takes the digitalized version of an analog signal and spreads it out over a wider bandwidth at a lower power level. This method is also called direct sequence spread spectrum as well. So the third generation 3G cell phone technology called CDMA based or wideband CDM. WCDMA uses a similar method, use compressed voice and 3 to 84 megabits shipping cores in a 5 megahertz channel to allow multiple users to share the same band. So nowadays, you know that the 5G network is we're using in our phone. The latest one, the 5G is, and but in 3G cell phone technology uses CDM based multiplex technique. Uh, um, Technique whereas the GSM we already learned that GSM use your TDMA. So here you will find the comparison between the all three. FDMA is frequency division multiple access. TDMA is the time division, and CDM is code division. In this sharing, the bandwidth among different stations takes place. In DMA, in TDMA, only the sharing of time of satellite transponder takes place. And in last one, the CDMA, in this there is a sharing of both bandwidth and time among the different stations that takes place. So if you compare these three, the only bandwidth is shared in FDMA, the sharing of time is takes place in TDMA, both the bandwidth and time is shared in CDMA. There is no need of any code word in FDMA. There is no need of any code word also in TDMA, but code word is necessary in CDMA. There is only need of guard bands between the adjacent channel are necessary. So you have a guard band which distinguishes one channel to another channel. So that there is a band known as a guard band. So it is used in FDMA. In this, guard time of the adjacent slot are necessary. But in this, both guard bands or guard time are necessary in CDMA. FDMA synchronization is not required because there's a different type of bandwidth is divided and a guard bands are used. So no synchronization is required. But synchronization is required in both TDMA and CDMA. Sorry, in TDMA. But in CDMA, no synchronization is required. The rate of data is low. The rate of data flow, data communication is low in case of FDMA. But the rate of data is medium in TDMA. It lies between FDMA and CDMA. But the rate of data is high in CDMA. Mode of data transfer is continuous signal. Mode of data transfer is signal burst. Mode of data signal is digital signal. So here is the CDMA is highly flexible, TDMA is moderately flexible, and your FDMA is little flexible. So you may get a question to write the comparison between these three or any two, either FDMA between TDMA or TDMA versus CDMA or CDMA versus FDMA. So you may write these points to distinguish them. The first mobile network or mobile communication which was used at a GSM. As we discussed, GSM use your TDMA, TDM technology, multiplexing technology. GSM stands for Global System for Mobile Communication. It is an open and digital cellular technology used for mobile communication. But you see, it uses four different frequency band of 80, 50 hertz, 900, 800 megahertz, or 900 megahertz. It uses the combination of FDMA and also TDM. So basically, it is TDM based, but it used some part combination of FDMA, where some band is divided into different frequencies. You see, 850, 900, 1800, 1900. So GSMA use the combination of both FDMA and TDMA. You see, supports international roaming, clear voice clarity. These are some features. Ability to support multiple handheld device, frequency efficiency, low power handheld device. The power is it consumes less power. Ease of accessing network, international ISDN compatibility. But you see, there is no video. There is no mobile TV. So nowadays we are see in a video. So there is no GSM does not have any video, mobile TV. So uh, you see there are the limited features at that time. GSM architecture. So this is important. Uh, I saw many times that the question comes about what is the architecture of a GSM, what is the feature of GSM, what is the GSM network. A GSM network comprises of many functional units. The architecture of the GSM, its network consists of many functional units. These function and interface are explained in these modules in this chapter. Basically, the GSM network can be broadly divided into uh, this following four subparts. First, the mobile station, then the base station subsystem, the network switch subsystem NSS, and the operations support subsystem OSS. So overall, architecture of GSM consists of these following four parts: MS mobile station, BSSS base station subsystem, NSS network switching system, and last one is OSS operation support subsystem. Let us discuss one by one. First, the MS. The mobile station. The MS consists of the physical equipment such as the radio transceiver, display and digital signal processor and the SIM card. That is, you know that you at least need the one machine or phone or any type of your that is which is consist of mobile station. So you must have a devices, such type of devices. So it consists of the physical equipment such as the any that contains radio transceiver, display, and digital signal processors. The processor must be there, and the SIM card is there. So all these are including in your mobile phone. It provides the air interface to the user in GSM network. As such, other services are also provided, which includes voice teleservices. You can communicate by voice, data bearer services, the features supplementary services. So the SIM provides personal mobility so that the user can have access to all subscribed services irrespective of both the location of the terminal and the use of the specific terminal. So we have a mobile SIM or small SIM in our devices. It needs to insert the SIM card into another GSM cellular phone to receive calls at that phone. So as you know, for communication, like a sender, there must be a corresponding receiver machine. So the SIM card is also uh, inserted uh, into another GSM cellular phone to receive calls at that phone, make calls from that phone or receive other subscriber services. So the first component is MS. The second is BSS, base station subsystem. The BSS is composed of two parts: the base transceiver station BTS and the base station controller BSC. The BTS and the BSC communicate across the specified abyss interface, enabling operation between components that are made by different suppliers. The radio component of a BSS may consist of 4 to 7 or 9 cells. A BSS may have one or more base stations. The BSS use the abyss interface between the BTS and BSC. So this is also required on architecture of the second part of the GSM network. You see, So this is your GSM BSS, base station subsystem, and it is there is a base connection. You see, there is two. Then see the BTS. The BTS houses the radio transceiver that define a cell and handles the radio-like protocol with the MS. In a large urban area, a large number of BTS may be deployed. You see, there are different type of MS are there, mobile station are there, but you see the GSM BTS, so it connect. There is a connection between the MS to BTS. So this BTS may be your cell phone, maybe in other devices, it may be a laptop. So so in a large urban area, the large number of BTS may be deployed. Each BTS serves as a single cell. It also includes the following function: encoding, encrypting, multiplexing, modulating, and feeding the RF signal to the antenna, transcoding and the rate of adoption, time and frequency synchronizing also, voice through full or half rate services. You know that the data which is encrypted, it must be decrypted. Which is encoded, it must have the decoded in the receiver center, receiver side. So if the data is encoded or encrypted in the sender side, it must be decoded or decrypted in the receiver side. And equalizing receive signal, random access detection, timing advances, uplink channel measurement. So these are the function of BTS. Then BSC, base station controller. So after BTS, the BSC manage the radio resources for one or more BTSs. It handles radio channel setup, frequency hopping, and handovers. So sometimes the frequency may weaken. So it is there is a technique to recover it. The BSC is the connection between the mobile and the MSC. So it is between the MS and the MSC. The BSC also transfer the 13 kbps voice channel used over the radio link to the standard 64 kbps channel used by the public switch network PSDN, public switches telephone network. It assign and release the frequencies and time slot for the MS. So it release the frequency or time slot for any mobile station. The BSC also handles intercell handovers. It controls the power transmission of the BSS and MS in its area. The function of the BSC is to allocate the necessary time slot between the BTS and the MSC. So it allocate the necessary time slots. It is a switching device that handles the radio resources. So the next component, important component, is NSS, network switching subsystem. So it is the main part of which the mobile switching center MSC perform the switching of calls between the mobile and the other fixed or mobile network. Suppose you are make a phone call from your mobile to other a fixed line mobile, from your mobile phone to a fixed. So it perform the switching of calls between the mobile and the other fixed or mobile network user, as well as the management of mobile service such as authentication. So it plays a vital role in the communication. The OSS, the operation support subsystem, the last part of the GSM architecture. The operation and maintenance center OMC is connected to all equipment in the switching system and to the base. As the name suggests, the operation subsystem, it is responsible for overall all operation and control all the operations. The implementation of OMC is called the operation and support system. Here is the sum of the functions, administration, and commercial operation, subscription, end terminal, charging, and statistics. It keeps all the data, statistics. Security management. It also provides the security. Network configuration. Which type of network configuration will be done? Operation and performance management and maintenance tax. Okay, so all the operation, overall operation is controlled by OSS. You see here. Following is the figure which shows how OMC system cover the GSM. So there is a BSC, BTS, MS. You see, there are different type of are there. So it controls OMC system covers all the GSM, other network, other component. Then GSM. So nowadays, GSM is very little user. There no user in GSM mobile due to its lack of the modern features. Uh, so after GSM, the another network uh, known as GPRS, General Packet Radio Service, which is defined as a mobile communication standard that operate on 2G and 3G cellular network. Now you know that nowadays the 5G network, you are using 5G network in our mobile phone, the latest technology. So but GPRS standard that operates on 2G and 3G cellular network to enable moderately high speed data transfer using packet based technology. So as compared to GSM, GSM is slower than the GPRS, so it provides moderate high speed data using packet based technology. The data are communicated here in the packet base. That is the whole entire is divided into smaller parts. The entire data is known as packets. How does GPRS work? You see here, there is a GPRS network, and you see the GPRS gateway which connected to the internet, and the GPRS network is connected to mobile phone as GPRS modem, and is connected Bluetooth and GPS also, which access protocol micro browser GPS mode. So this GPS network and working of the GPS network. How GPS establishes a connected mobile environment. Uh, General packet radio service (GPRS) packet service is essentially a packet switching technology that allows information to be transmitted via mobile networks. This is utilized for internet connectivity, multimedia messaging service, and other type of data transmission. So internet connectivity to provide this picture internet connectivity, multimedia messaging. You can send data, any type of audio or video data, and other type of data transmission. GPRS is supported by GPS is supported by GPS cell phones. So a cell phone having GPRS network enabled, so it is supported by GPS cell phones as well as laptops and any handheld device equipped with GPRS modem. You see the in previous picture there is a GPS modem. So there is a devices which is equipped with a GPS modem can access the GPS network. Subscriber have reported downstream bandwidth of up to 80 kbps. So their downstream bandwidth speed is up to 80 kbps. Let us discuss what are some advantages and challenges of GPRS. Compared to the GSM, we have already discussed what is GSM network and what are the features and also its architecture. So compared to that network, GPS technology provides various perks and advantages to user and network provider. Companies commonly use this to create precise data capabilities using mobile communication technology. The benefits are, you see, billing made simple. That is, your billing makes simple. It has some increased speed. The speed is more as compared to the GPS network and always on connectivity. So it is the always on. It is always on. So so these are the benefits that are discussed. How billing made simple. When compared to the circuit switches services, GPS packet transfer offers better consuming bills. So as the data is transmitted in packet based, so billing is simple. So when compared to the circuit switches services, GPRS packet transfer offers better consumer billing. When it comes to circuit switches service, the cost is determined by the length of the connection. But here the cost is determined by the packet, length of the packet. One of the significant disadvantages of circuit switching for IoT is cost effectivity. The connection length determines the subscriber operating cost in the circuit switch. So this is the disadvantage of circuit switching, not packet switching. For IoT, Internet of Things, is cost effective. Why? The connection length determines the subscriber operating cost in the circuit switch. The second is increased speed. The significant advantages of the GPRS system is that it provides a higher data rate than GSM. GSM was designed to transmit data at approximately 14.4 kilobits at first over the 2G network. GPRS, on the other hand, provide data speed up to 86 kbits. So the data rates is comparatively higher in GPS network. Always on connectivity. Another benefit of GPRS is that it is always available. A GPRS connection can provide constant internet connectivity, quick messaging, and improved SMS transfers. It was also the fastest network ever seen when it was first launched. So when it was first launched, it was the fastest after GSM. For example, with a standard GSM communication technology, somebody could transmit only 10 SMS per minute at that time. So it is considered as the fastest network at that time when it was the first launched. So sometimes between the 2G and 3G network, uh, another network which is better than 2G is known as 2.5G. It is not widely used, so we may not heard about 2.5G, but enhancement that provide packet data capability over 2G network, 2.5G improves the availability data rate supported by the air interface, thereby permitting the introduction of new data-oriented service and applications. The increased data rate rise up to theoretically maximum 384 kbps. Although in the field available data rates may often be as low as 20 kbps, general packet radio service is an example of 2.5G technology. So you then the next generation is after 2G, it is 3G, third generation mobile phones. Let us see what is 3G mobile phones and what are its features. Third generation mobile phones or 3G internet mobile phones is a set of standard for wireless mobile communication system that promises to deliver quality multimedia services along with high quality voice transmission. Let us see, there are some features. Three G system compiled with the IMT 2000 International Mobile Telecommunication 2000 standard. Specification by Internal Telecommunication Union. The first 3G service were available in 1998, about 26, 28, 28 years ago. So the 3G service are available in 1998. It provides high-speed transmission having data transfer rate in 0.2 Mbps. So as compared to 2G network, it provides better transmission speed. Global roaming service are available for both voice and data. So the global roaming service are available. That is, if you are traveling outside of the country, the roaming you will get the roaming services, global roaming services. It offers advanced multimedia access like playing music, viewing video, television services. These features was not available in GSM network. No television services are there. No videos are there. It provides access to all advanced internet services. For example, surfing web page with audio and video. So these are the features of 3G mobile phones. Area of some application. Wireless voice telephony, fixed wireless internet access, wireless access telephony, that is you can make any voice communication while you are moving. Mobile internet access, you can access the internet in your mobile phone. Video calls, you can perform any video calls. Mobile TV technology, video on demand, video conference, GPS system, that is you can access the network, location based service. So these are the areas of application of 3G mobile phones, 3G network phones. Then After 3G, the fourth generation, 4G mobiles. 4G mobile phones, nowadays also you can use the 4G in some devices where the 5G is not supported. So some mobile devices are using 4G network, and also some operator providing 4G. So they are not providing the 5G instead. So uh, 4G mobile phones provide broadband cellular network services and is successor to 3G mobile network. It provides in all IP-based cellular communication. The capabilities provided adhere to IMT advanced specification and labeled by ITU. So it provides this specification. It provides an all IP packet switches network for transmission of voice, data, signal, and multimedia. So like your GPRS, it also provides an IP packet switches network. It not circuit switches, it is packet switches network. Like your GPRS. GPRS network or 2G or 3G, it also packet switches network. It aims to provide high quality uninterrupted services to any location at any time. It provides high quality uninterrupted services, irrespective of any location or at any time. 4G networks should have peak data rates of 100 Mbps for highly mobile station like train, car. When you are moving, like a fast moving vehicles like train or car, it provides the data rate is 100 Mbps and 1 Gbps for low mobility station like residence. So when you are staying in residence, so this data transmission speed data rate is 1 Gbps. So you may compare this value with the previous network. It is much better or much faster. It also lays down that 4G network should make it possible for 1 Gbps downlink over less than 67 megahertz bandwidth. They provide have smooth handoffs across the heterogeneous network area where the network are different. Where the network are different, it provides the services as well. LT, long term evolution. You may heard about the 4G LTE. Okay, so let us discuss what is that LTE. Long term evolution or LTE is an extension of 3G technology. Uh, it is a standard for high speed mobile communication based upon GSM, Edge, and UMTS or HSPA technology. The peak data rates for download is 100 Mbps and upload is 50 Mbps. The LTE Advanced meets the specification of IMT Advanced standard for 4G technology. Its peak data rates are 1000 Mbps and downlink is 500 Mbps for upload or uplink. So the LTE is another technology basically used after the 3G technology. So I recall I used at that time, that is 4G LTE. So this is long term evolution. So basically it is come to market after 3G technology. And you see the speed is better or higher than the previous one. Application area, advanced mobile web access. So you can access the web with using the mobile phones. So mobile web access, IP telephony, internet protocol. You know that this is IP telephony. High resolution, high speed gaming services. So the gaming services are there. High resolution, high speed gaming services. Stream multimedia and data. You can use the streamed multimedia data That is, you can video, you can play any video or audio. High definition mobile TV, HD mobile TV, you can view it in it. Video conferencing, you can make a video calls using multiple users. And 3D television. So also it supported 3D television. So these are the 4G features. And now we have also used the all the features which are discussed here. Okay, IP telephony, video gaming, streamed multimedia data, high definition mobile TV, video conferencing, and 3D television. So this architecture represents the mobile computing architecture. So what are the architecture of mobile computing? This is, you may get a question from here, mobile computing architecture. This architecture represents the blueprint about the multimedia layers in between network hardware components, devices, and user application interface. Well-established architecture is required for getting to access data, systematic calculation, and software object as well. So well-established architecture is required for these purposes. Otherwise, the security will be lost, the data will be lost, and also the data communication will be not done properly. So a well-established architecture is required for getting to access data, systematic calculation, and software object as well. And this architecture is known as three-tier architecture of mobile computing. As it is contain three different layers, that is why the name is three-tier architecture of mobile computing. Let us discuss what is the three-tier architecture. What are the different components it contains? Mobile computing is enabled with three-tier architecture that has three major layers. So here we will explain each one layer on its function. So as the name suggests, it contains three-tier architecture. It contains three important layers. Mobile computing architecture layer. First layer is presentation layer. So as is the name presentation layer, this layer lets user to face device handling and rendering. So it is closer to the user. How the data is represented. How the presentation layer. The layer let the user to face device. Users to face device handling and rendering. So this layer is, you can tell, is close to the user. So application layer, it allows executing business logic and rules. It allows business logic and there are some rules, there is some BGM logic, how the data is represented. Data, it does not contain the actual data. The actual data is stored any other layer. Okay. So but the data is presented in presented layer so that the user can view it. To present data, there are some rules are required, some business logic are required. So this that contain in the application layer. And the last one is data access layer, DM. It lets to get access and management to the actual data. So there are three different layers in mobile computing architecture. These are known as the mobile computing architecture layers. You see, this is the block diagram of mobile computing architecture. So the tier 1, first layer, tier 2 and tier 3. Tier 1 is close to the user interface, user presentation. So it is known as the presentation layer. But the middle layer, the tier 2 layer, you see it contains some business tags, business rules, business logic, how the data is presented to the users. But the actual data is available in tier 3. Where the data is data store. You see there data store. There is some symbol of some cylinder which contain that data is stored here permanently. So there is no direct interface between the tier 1 and the tier 3. So you can consider the tier 2 is the interface between the tier 1 and tier 3. So when data is presented to the user, data basically comes from the tier 3 where data is permanently stored through the tier 2, the middle tier, which is also known as PBSUC application layer. It provides some business logic, some business tags, some rules in which manner data is be displayed. Let us discuss the three layer briefly. First is one tier presentation layer. First layer, that is presentation layer. You see, this presentation layer is used to execute all application on the client device and provide complete user interface. And it provide complete user interface, so it is close to the user. So how it is presented in the mobile devices or client devices? So presentation layer is responsible for that. It has main responsibility is to present information to the user. So if the data is not present to the user, so the user may not use it. If user do not use it, so the device is meaningless. So it has main responsibility is to present the information to the user. Suppose you are browsing the internet. You know that your mobile screen is fixed or smaller in size as compared to other devices. Suppose you are using a laptop, you are using a your mobile phone, and you are browsing the data. Your screen, the laptop screen is bigger than your mobile screen. So how the same data is present in the mobile screen and as well as in the laptop screen. Okay, so this is the presentation layer. Users are able to grab all information via speaker, vibrations, or screens. So you can grab all the data through any output devices, either it is speaker or your mobile phone or mobile screen. User can send the information with helping of input devices like pen drive, mouse, keyboard, touch screen, and so on. So the corresponding keyboard device are there, input device are there. Suppose you click the mouse using a mouse or keyboard, or you type something in your browser through keyboard, and when you press the enter key, so the data will be displayed in the output devices on the screen. This layer is enabled with WA browser. So when you are browsing the data, so there are wireless access protocol browsers are must be there. So to access the web page or to access the data, you must have a suitable browser. So web browser is supported by the your device must be supported by the WAP browsers to view these pages or view the data. So the layer is enabled with the web browsers. So this presentation layer is enabled with the web browser, customized client program, web browser, etc. So this is enabled with these type of programs or these type of softwares. Presentation layer allow accompanies via client slide data resource, dynamic HTML, and data cursors. Second, the middle layer. 1 minute. So after the first tier presentation, the second layer is second the application layer. So the first layer, presentation layer, which is responsible of present the data to the user. So it is close to the user interface. So the application layer, business logic perform all tasks as server for client request from the workstation. It works as business rules, fetch or enter data through the data layer. Uh, um, it is enabled with few technology like PHP, .NET services, Java server pages, or Java, and so on. So presentation and database independent. So presentation layer and database are independent. Uh, so the layer identifies that which type of data is required and performs as client is relation to a third tier or programming that may be situated on a mainframe computer or locally. So the application layer, the business logic are performs all tasks as server for client request from workstation. So when you request some data, it go to the server. Then uh, from the server, the data comes to the user mobiles. So this is there are some standard rules or standards business logic in which manner data is represented to the user. Uh, um, it is performed by the second layer, the application layer. You may tell that it is an interface between the layer 1, tier 1 and tier 3, layer 1 and layer 3, because there is no direct user interface from the tier 1 to the tier 3 where data is actually present. So it is enable of few technologies, PHP, .NET service, JSP, Java, unlike your previous layer which is enabled with the web browsers. It take decision on rendering network management, security, data store access, need for many types of middlewares. So it is under the network management, how the network manage the data, in which route data will be sent. Security, it is also check the data authorization, that is the user is authorized or not. It may provide some user ID and passwords and such type of techniques to provide security. Data is encrypted or decrypted. Suppose data is present in database layer or third layer, it presented to the first layer. So when data is passing, so it may add some encrypted rule. Data is encrypted to a certain form so that no one can hack it. Data store access, in which manner data is stored. Need for many types of middlewares. Their components are not linked to certain client, so they can be implemented by all application and can be processed to other location as responding time frame and other needs rules. So the second data is interface, as we discussed, it is interface between the first layer and tier 3. Last layer. This layer is implemented to keep store data that is required by application and work as a repository for both temporary and permanent data. So this layer is implemented to key store data. So data is actually stored in this layer. Data access layer is built up of DBMS. You please recall the first layer is consists of some browsers. The second is some technology like PHP is enabled with PHP, JSP, or Java, or .NET. But the data access layer is built up some DBMS software that offers all data for above two layer. This, as it is stored data, so it must need a DBMS software. This layer is also known as DBMS access layer, database management system access layer. All data is stored into many format like a text file or related database. So data, either any related data or any format it can store. So as data is stored here, so this layer is built of some DBMS that offer all data for above two layers, which provide the data to above two layers. So it is enabled with the any DBMS package. So this is the three-tier architecture. You see here, the first one is tier 1, tier 2, and tier 3 type data access layer. So this is the architecture of mobile computing. You may get a question right about the three-tier architecture of mobile computing. So you must write these three tiers and their functions. The first one, the presentation layer, closer to the user. The middle layer, which is provide the business logic and some rules, and the actual data is stored in the last layer, which enable them DBMS software. IP. You may heard about any type protocols. From beginning, we have discussed that out of five components: sender, receiver, data, media, transmission media, and the fifth important is protocol. So the absent of anyone, if there is the absent of anyone, you cannot perform any communication. So protocol also is a component which is required for data communication. Any type of communication you perform communication whether through wired device or wireless device. These five component are required. So among these five component, protocol is also an important component for data communication. So whenever you may heard about some protocols, internet protocol IP, TCP, transmission control protocol, TCP/IP, UDP, user data protocols, POP, post office protocols, SMTP, uh, your FTP, file transfer protocol, SMTP, simple mail transfer protocol. You may heard about these protocols. Similarly, when you are using mobile data, mobile communication, so the protocol which is required is known as mobile IP. We may use IP only, TCP/IP, IP along with TCP, known as TCP/IP, and so other protocol also we have already discussed: POP, SMTP, FTP, UDP, okay, TCP. So similarly, to perform any communication with the mobile application or mobile devices, and protocol is required, and that is known as your mobile internet protocol, mobile IP. Okay. So mobile IP also an important. You mark it as important. It may you comes in exam. The mobile IP architectures, We'll discuss the architecture of mobile IP is important. These are okay. So mobile IP, shortly known as MIP. It is shortly known as MIP. Is an Internet Engineering Task Force IETA or RFC 2002 de facto standard communication protocol. So it is a communication protocol. It is created by extending Internet Protocol IP. I have already discussed. We know that there's IP is a protocol, Internet Protocol IP. We, along with TCP IP, we may heard about the TCP IP. So it is a extended form of Internet Protocol known as MIP, and it is basically used for mobile communication. The mobile IP allows mobile devices to move from one network to another while maintaining the same permanent IP address. That is, we may think about that when we are moving, our communication will not drop. There is no disconnection. But we are leaving one network and entering a new another new net. We are leaving from our existing network and entering a new network. Our internal IP address of our device may changes, but the mobile IP allow the mobile device user to move from one network to another while maintaining the same permanent IP address. So this is possible to maintain the same permanent IP address by using this protocol. This is important. When moving from one network, when suppose you are moving a car, you are leaving a existing network and entering a new network. So at that time, you are maintaining the same permanent IP address. Okay. This work is performed by this protocol, mobile IP. The concept and role of the mobile IP are very important in the field of mobile computing technology. The mobile IP makes the communication flawless and ensures that the communication will occur without the user session or communication be dropped. The communication will not drop. You will continue its communication. So this is the overall work of mobile IP. That is the only idea about mobile IP. And the architecture is sorry. The architecture of mobile IP technology we'll discuss in the next class. So please write your name and number. Those who have not written in the board so that we can give the attendance. Please do not leave. I will take the snapshot. A minute.